Okay, so 9.2.2, the same as find probability of B. So we are given probability of A or B, and probability of A and B, and so probability of B is equal to is 4 times probability of A. So since we're given probability of A or B, think about your addition rule formula, which is probability of A or B. So for your 9.22, you will have probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Probability of A or B we are given that it is 0.83. So I've got 0.83 here. Probability of A we're not given. Probability of B, they said it's 4 times probability of A. So it's going to be 4 times probability of A. So we end up having only one unknown. It's going to be 4 times probability of A minus probability of A and B. We're given that it is 0.12. 0.12. So you solve for probability of A, transpose this to the other side, becomes a plus, left with 5 probability of A here. Then we'll divide both sides by 5. You will then get that probability of A is equal to, so I'm getting 0.19. What was the question? It said probability of B. So we're not done. Probability of B, we said it is 5 times probability of A. So it's going to be 5 times 0.19, which will give us 0.95. That's probability of B. And you can see the probability of B is very high compared to probability of A. Probability of A is 0.19, probability of B is 0.95. So B is more likely to occur compared to A. Then 9.2.3, they say find probability of not A. Probability of not A. Okay. So you might need to make an assumption here that A, events A and B are complementary. Because notice they are mutually exclusive, but I'm not sure if they are exhaustive or not. So for me, I would make an assumption and just say assume that A and B, so when I say not just A, but when I say events, because A and B are events A and B are complementary, and it means that they are mutually exclusive and exhaustive. Actually, they are not mutually exclusive. They are not in this case. That is very interesting. Okay, the question might have an error because these two events are not even mutually exclusive, so they can't be complementary. But it's fine, you can just assume that they are complementary and just see how we do that if they were complementary. So we would say probability of A plus probability of B is equal to 1. It's the same thing, probability of A plus probability of not A. Of not A, which you could put as A prime if you like. Probability of not A is equal to 1. And then probability of A, we found it. Probability of A, we found it to be 0.19. So we'll have 0.19. Probability of node A would end up being 1 minus 0.19, which would give us 0.81. Okay, see now, so but it shouldn't be B here, it should be node A. Why? Because it looks like A and B are not complementary, but now A and node A are complementary, because it's gonna be something like this. It's either you are in A or you are something else that you don't know. It could be B or something else here. So now A plus node A will always give you probability of 1 if you sum them. Same thing, probability of B plus probability of node B, it would give you 1. Because either you are in A or it's either you are B or you are not B. And if you're not B, you could be anything else if you're not B. But as long as you're not B, as long as you are either A or not A, or it's B or not B. So probability of any event and not that event will always sum up to 1. Just the baseline. Then last example, here we're given that E and F are two independent events. Before even look at the rest of the question, write down your condition for independent. So they are independent, which means that probability of A and B, multiplying them, it's going to be A times probability of B. But if the mutually exclusive is going to be equal to 0. Don't confuse those two conditions. So then I say probability of E is X and F is that one. So we could have used E here. Set probability of E and F equals probability of E times probability of F. Okay, and then we given probability of E and F is that, and E of F is there. So I must show this. So these, they are Y. So basically this is going to be Y times Y. It's going to be Y squared, because we given that this, they are both equal to Y. So probability of E and F is Y squared. But now probability of A and F is that one. Probability of E and F is that one. So since we're given probability of E or F, that hints us that you must use the probability rule, or probability addition rule formula. It says probability of A or B is equal to that probability of A or B would be 9/10. Probability of A is Y, probability of B is also Y. Okay, I'm using A and B instead of using F here. So I should be using F. So the same probability of E or F. So this should be E. This should be F. That should be E. That should be F. Sorry about that. Then we've got here probability of A and B. We said it is Y squared. So it's Y squared. And then if you simplify this out, you will get that this is 2. This is going to be 10y. It's going to be 10y squared. And then if you simplify this out, you should basically get the answer.